let's start by introducing myself. So I'm Cristina Oliveira, and I work in Atractor. And Atractor is a non-profit Portuguese association which aims to, as the name implies, to attract. And in this case, it aims to attract to mathematics. And we started to be very focused on physical exhibits. For instance, these are examples and there are photographs of a big exhibition that we had in Lisbon. It was in the main science center in Portugal, and it was there for more than 10 years. It was called Maths Alive. This is a photo of our exhibition. This is a real Ames room. There are no giants here or the dwarfs. This is ordinary people in an Ames room, and this is there is no Photoshop in this photo. This was an image, a photograph that was taken in that exhibition in Lisbon. But however, for several reasons, at a certain point in Atractor's history, we started focusing on the virtual part, and now we mainly produce contents virtually. And this is our website. It has more than 2,000 pages devoted to popularization of mathematics. It's profoundly illustrated. You can find a lot of apps, a lot of animations, a lot of images. And in the past, our website had a drawback because it was written in Portuguese. But now, due to a collaboration with mathematicians from the Science Center of the Coimbra University here in Portugal, most of our website is translated. So you can now visit our website. I invite you to visit our website, and and see all the materials that we have there. This is just an example of a web page that you can find. This is about mathematical models of shells. You're seeing here a static image, but everything that you find in this web page and in many of our web pages, it's interactive. So you can manipulate, you can see the images, you can try new shells, and you can try to see and to discover how this model works. This is a mathematical model. It's not very difficult. And with this model, you can, just with a model, you can create all the shells that exist in nature. Actually, you can create even more shells that don't exist in nature. But this is just to give you one example of things that you might find in our website. I invite you all to try and to see our contents. We also offer free software. So this is one of the apps that you can find. It's called ATR Mini. ATR comes from Atractor. It is devoted to children up to 10 years old. You can find an app for PC, but this is also available, and it's available for free. It's available in App Store and in Google Play Store. And you can download it and try it. And actually, a funny part concerning this app in particular is that we found out recently from Google Play that ATR Mini is very much imported in China. This was a very big surprise for us. And this is a bit of the funny part of doing things online. You never know where your contents are being used and by whom. And this was a nice surprise. Well, and just to finish the part about Atractor, this is our YouTube channel. You can also find it in our website. There's a link for it. It has more than 20 films, small films, we call them math labs, and about different subjects. One of them is symmetry, but other subjects also. And I invite you to see our films and, well, to see our experiences and our proposals that are there. Well, and finally, here are our references. So again, we have our site, you have our YouTube channel, which I mentioned just before, and of course you have our Facebook, and then again our email if you want to contact us or if you have any doubts. So okay, so our main role now, going to Symmetry Fair and to Mathina project, our main role in this project is, and our main contribution is the symmetry part. So we were responsible by Symmetry Fair and by the contents which are related to symmetry. And why did we choose symmetry? Well, we had two goals. One of our goals is to help visitors in Mathina world to deepen various concepts that arise from their own empirical experience, because symmetry is something that comes a lot from our experience, but we want to deepen and to relate them to mathematics. Another one of our goals is to do in a playful and interactive way to make visitors discover what symmetry is, and also to help them distinguish between different types of symmetry. So this was our goals when we started the symmetry part in the Mathina project. Well, I will just interrupt the sharing for a moment because I would like now to share my, okay. I'd like to share, let's share again. Oh. Okay, so I would like to share the website. Are you seeing the website?
Yes, we are.
Okay, great. Okay, so I won't have much time to show you the symmetry parts, but I can show you some examples. And my idea now is to concentrate in one of the stories. And the story that I would like to show you is, I'm going now to the, sorry, not here, to the symmetry part. And I'm going to focus in the story Stamping Freezes. This is a story for 11, 14 years old, but it can also be explored by other age groups. So I'm just going to open now. So what happens in Stamping Freezes is that when Mathina and Leo arrived to Symmetry Fair, they get to know the wizard who is responsible for Symmetry Fair. And here is the wizard. And the wizard is stamping beautiful friezes in the roads, but he's stamping them in a traditional way. And we can see how the wizard is stamping. I'm just going, okay. So if I open this film, you can see that he's stamping like this. So you have to imagine that the board has ink on it, and he's stamping like he would do if he had a traditional stamp. This is what he would do with a traditional stamp. Well, but meanwhile, the wizard has to go to the castle, and he has to go to the castle because the ink of the board, this board, is finishing. But the board is difficult to transport. And why is it difficult to transport? Because it's big. And the wizard is using his magic broom. So they decide to roll the board and to stick that roll in the wizard's broom. So they make a roll. And while the characters are distracted talking, they don't notice that the roll starts rolling and is stamping a freeze. So we can see it here now. So the two characters, Mathina and Leo, are very worried because the roll started to roll. But on the contrary, the wizard is completely thrilled. And he's thrilled because the roll is stamping the freeze automatically. There is no need for any effort because it's doing it by itself in a much easier way. And why did this happen? This happened because the roll, the cylinder, is the good stamp for freezes which only have translation symmetry. So we can go on. So now they are very happy because they can stamp freezes very easily. So here you can choose an image you want. You can create a cylinder, and you have to imagine that the cylinder has ink on it. And then you can see the creation of a freeze. Just have to press this button. You see the creation of a freeze, and this freeze will have as a motif the image you chose. And now you can choose the image and print other freezes. And this will lead to several discoveries from the main characters, Leo and Mathina. For instance, they notice that, okay, so the wizard now goes to the castle, and they notice that the freezes, they are an important feature in the freezes. There are freezes that have symmetry axes, and there are freezes that don't have symmetry axes. They also discover another interesting feature, is that in the freezes, if you look to the freezes which have symmetry axes, there are three kinds of freezes. There are the ones which only have vertical symmetry axes. Then there are the ones which only have horizontal symmetry axes. And then you can find the ones that have both kind of axes. So they go on experimenting and doing a lot of trials. They stamp and create new stamps. Just go forward. They also notice that if you want to stamp a freeze that has both vertical and horizontal symmetry axes, you don't need a roll. You can do it only with a board. The board should have ink on both sides. And if you use these movements, you can very easily imprint a freeze which has both vertical and horizontal symmetry axes. And so they go on with making a lot of discoveries, which I invite you to test. They discover, for instance, that a freeze can have rotation symmetry, like this one. They discover, well, they go on with stamping freezes and in different ways and finding new stamps. And later on, they discover that a freeze can have glide reflection symmetry. So we can see it here, an example of a freeze that has glide reflection symmetry. So if you reflect and you move a little forward, the freeze goes onto itself. Well, they keep on making experiments. They discover that all freezes have translation symmetry, which you can see here. Sorry, just want to go this one. And finally, they discover that they arrive to all the different types or symmetry groups that exist for the friezes. And there are only 7 types of friezes. This is a theorem, and they arrive to the 7 types of friezes. And now, when they arrived and they have split the friezes in different bags, they can now choose for each bag the symmetries that exist in the friezes in each bag. For instance, if you choose this bag, this is a bag which has translation symmetry, which should have horizontal reflection symmetry, and also has light reflection symmetry. And then they can move on and do the same for all 7 bags, which correspond to the all 7 types of friezes that exist. So this is one of the stories. I don't know if I have more time or not. I don't know how I'm in time. Sorry.
We are in general a little bit out of time, but if you show still what you want, quickly, that's fine.
Okay, thank you. So I'll just show a very little part. I invite you all to try all the stories. As I mentioned, I won't have time to do it all. I'm just going to show a bit of the second story. So here, Mathina, this is for the 7-10 years old. So Mathina again arrives to Symmetry Fair. She's invited to play a game related with rosettes, but she does not remember what a symmetry axis is. So she can make some trials by dragging a mirror. For instance, here, if you drag the mirror and you put the mirror here, you can see that this image has a reflection symmetry. It has a symmetry axis. And then she can go on and play the game. And there are several games related to rosettes. I just will show one of them. But again, I invite you all to try this game. For instance, here, she has to put the rosettes in the good bags. And which are the good bags? Well, now we are dealing with rotation symmetry, so we should count the number of rotation symmetries that this image has. And you can do it by dragging the image and seeing how many times these 2 images, the one that's underneath and the one which is above, how many times they overlap. And if you do that, you can find that this will happen 3 times. So this bag, this rosette, should go to bag number 3. Okay, this is just a game. And well, just to finish, because I know we are short in time, I'd like to show you just one more app. At a certain point, Leo, Mathina's brother, and Mathina decide to continue exploring all the fun and all the diversions that exist in Symmetry Fair, and they decide to enter a mirror maze. And I'm just going to show a bit of this mirror maze. So when we enter this mirror maze, which is here, you have to solve a maze. And this seems a very easy and ordinary maze. But when you start solving it, at a certain point, you cannot see your path in the left. But you are in a magic vault. Symmetry Fair is a magic vault. And you have on your right a mirror, a magic mirror. And you can see the image in the mirror. So to guide yourself, you have to follow the reflected image which is appearing on the right. And in this way, and with this app, you can, in a playful and interactive way, to explore and to train notions related with reflection. So this is, for instance, one. And then the magic mazes are getting more and more and more difficult, okay? So this would be a mirror maze that you had to solve, and the mazes get more and more difficult. And then we have a similar one, but instead of a mirror, what you have is a maze which is rotated. So this is a rotated image of the original mirror. I can see the original mirror here, and it was rotated by half a turn, so 180 degrees. It was rotated in this point. So now you have to solve the maze by looking to the rotation image. So now, in a playful, again, and interactive way, you can train properties related with rotation by solving mirrors, okay? And again, the mirrors get more and more difficult. Okay, so maybe I can stop. But my idea is that, well, I'm just showing a bit and in a very quick way because the time is limited, but I invite you all to try our stories and to read our stories and explore our films and explore all our apps. Okay, thank you.